Good morning, everyone. So last class, we talked about multiplying monomials times polynomials. So something like this times this. This is our monomial. This is our polynomial. So then we would distribute this. I have 2x times x, so that gives me 2x squared. Because these are both an exponent of 1, I'm adding those exponents. Then I have 2x times 1, which would just give me 2x. And then this would be my final answer. Today we're going to beef it up a little bit. And we're going to be multiplying first binomials times binomials. There are 3 different ways that you can multiply binomials times binomials. The main way that we are going to focus on in this class is the distributive property. So we can do it by the FOIL method and we can do it by a box method, but I'm actually going to squiggle these ones out as those are not ones that we are going to discuss. I think if I teach you 3 different ways, it's going to be a little confusing, so I'm just going to stick to one method that I think is pretty foolproof. So with the distributive method, okay, we always need to make sure that each term multiplies by both terms in the other parentheses. So this y has to multiply by both terms in the other parentheses. Okay, so I can take this y out and multiply by y plus 1. Okay, if that helps you visually, you can pull that y out, multiply it by y plus 1. Then we also can pull that positive 8 out, multiply it by y plus 1 as well. So both of these terms have to multiply by both terms in the other parentheses. So this 8 also has to multiply by both of those terms. So this is just a way to rewrite it out that would make it a little bit easier. I just took the 2 terms from the first parenthesis, wrote them out here, and I'm multiplying them by that second parenthesis. Now, in order to multiply here, I'm going back to what we did last class, that monomial times a polynomial, distributing. Y times y gives me y squared. Y times 1 gives me y. Or if you put 1y, that's also okay. Then I got to distribute here. 8 times y gives me 8y. And 8 times 1 gives me 8. The last step here is always to combine our like terms. So I have y squared first. That's definitely my largest degree, and it has no like terms, so I'm going to write it down. In the middle, I have like terms here. I have 1y and 8y, which combines to be 9y. And then this positive 8 comes down. And this would be my final answer after I distribute. Just giving everybody a second to make sure they have that down. Okay, so then looking at number 2, we're going to do the same thing. We're going to double distribute. So I'm going to take this k first, and I'm going to multiply it by both terms in that other parenthesis. So k plus 5. And then I'm going to take this negative 4 and multiply it by both terms in this parenthesis as well. Notice that I'm taking that negative sign with me. That relates to that 4. Now I'll do k times k to get k squared, k times 5 to get 5k, negative 4 times k to get negative 4k, and negative 4 times 5 to get negative 20. Now I've got to simplify this. My k squared is going to be first. It has no friends, no like terms. I do have like terms in the middle here. I have 5k minus 4k, which gives me 1k, and that negative 20 comes down. And this would be my final answer. Just making sure we're still recording here. It's been a little finicky for me lately. Okay, so we're skipping those next 2 methods. We're not going to do those. So now on this sheet, we have some multiplying binomials that I want you to try. I want to go over number 12 and number 16 before you get started on your own. So the reason I want to go over these is because number 12 has two variables in it. So it can get a little tricky. Okay, so once again, I'm doing the same thing. I'm pulling this 2a, and I'm going to distribute it to both terms in that second set of parentheses. So I'm going to multiply that 2a times a minus 4b. Next, I'm going to take this positive 5b, multiply it by both terms. So I have positive 5b out here, and I'm multiplying it by that second set of parentheses. Now I'm going to distribute. So I have 2a times a, that gives me 2a squared. 2a times negative 4b, so I'm going to multiply the 2 times the negative 4 first, that's negative 8, and then I just have ab. Okay, a and b can't combine at all, they're two different variables. Then I'm going to distribute here, I get 5ab. Remember, you always want those in alphabetical order, so don't put ba, make sure you put ab. And then 5b times negative 4b, 5 times negative 4 is negative 20, and then b times b is going to give me b squared. Okay, now I do have a pair of like terms here. They're right in the middle. I have negative 8ab plus 5ab. Now this is where if you had put ba, you could have gotten into some trouble. These are like terms, but if you had switched it around and wrote ba, you could have got confused and thought they weren't. So you got to pay attention. That 2a squared is going to come first, okay? And then I am going to do the negative 20b squared next. And then I'm going to combine these like terms. Negative 8 plus 5, that's going to give me a negative 3ab. And this would be your final answer. Okay, we can't combine that any further. And then problems like number 16, they're squaring something. So remember, if I do 4 squared, that's 4 times 4. So it's the same thing with something like this. If I have p minus 7 squared, I just want to write that p minus 7 out times itself. So write it out twice. And now I'm doing the same process that I've been doing. I'm going to take this term and multiply it by both terms in that parenthesis, so p minus 7. And then I'm going to take this negative 7 and multiply it by both terms in the last parenthesis. It looks a little confusing just because they're the same, but it's the same process. You just have to know to turn this into multiplying by itself. Okay. Now distribute. So I have p times p to get p squared, p times negative 7 to get negative 7p, and then I'm going to do negative 7 times p again here, another negative 7p, and then negative 7 times negative 7, that's going to give me a positive 49. Okay, my like terms are in the middle here. You'll notice that that kind of happens a lot with these problems when you're doing binomial times binomial. And negative 7 and negative 7 combines to give me a negative 14p. And this would be my final answer. All right. So I want you guys to take some time, pause the video, try to do 11, 13, 14, 15, 17, and 18 at home. And then I will post an answer key on my post in order for you to check it out. Okay, so at this time, pause the video, try to do those problems on your own. You are going to upload those as classwork today. And then come back into the video and you will see me go over the next page. So at this time, you should be returning from pause. If you are returning from pause, I'm just going to go over how we would multiply a binomial times a trinomial. It's very similar to what we were just doing. So same thing in this first parenthesis. I'm going to take one term and I'm going to multiply it and distribute it to everything in that second parenthesis. So I'm going to rewrite this second parenthesis right here. Okay, and then I'm going to take this second term in my binomial and also multiply it by everything. So I'm going to take this positive 4 and multiply it by everything in here. So now I'm going to distribute. X times x squared is going to give me x cubed. X times 3x is going to give me 3x squared. And x times negative 6 is going to give me negative 6x. Then I'm going to distribute this 4 to get 4x squared. 4 times 3x is going to give me 12x. And 4 times negative 6 is going to give me negative 24. Now I'm going to combine my like terms. I'm looking for that largest degree first. The largest degree I see is the power of 3. And I don't see any like terms, so I'm just going to bring it down. My next power would be to the power of 2, which I see here and here. So I'm going to combine 3 and 4 to get 7x squared. Then I see the power of 1 right here and right here. So I'm going to combine negative 6 and 12 to get positive 6x. And then lastly, I have this negative 24. So this would be my final answer. All right. I am going to do number 21 as well. So I start out with this 3a. I want it to multiply by everything in this trinomial. So 3a times this whole parenthesis, 5a squared plus 2a minus 6. Then this 1 needs to multiply by everything in that trinomial as well. So I have this positive 1 times this whole trinomial. So I'm going to do 3a times 5a squared. That's going to give me 15a to the power of 3. So I'm multiplying that 3 times 5 to get 15, adding those exponents 1 and 2 to get 3. Then 3a times 2a is going to give me 6a squared. And 3a times negative 6 is going to give me negative 18a. Now I got to take care of over here. And if you notice, guys, I'm just multiplying by a positive 1. So pretty much everything is going to stay the same. So 1 times 5a squared is just going to give me 5a squared. 1 times 2a is going to give me 2a. And 1 times negative 6 is going to give me negative 6. Now I got to combine my like terms. So the largest degree I have is this 3. So I'm going to put that first because it has no like terms to combine with. Next, I have the power of 2. I'm going to combine those. So I have 6 and 5 combined to be 11a squared. And then lastly, I have this negative 18a and 2a that can combine to give me negative 16a. And then this negative 6 has no like terms, so I'll bring it down. And this would be my final answer. We always want our final answers to be in that standard form, descending order of degree. The last problem I want to go over is 23, and then I'm going to have you guys at the end of this video. I want you to try 20 and 22. If you are at home today, you are uploading a photo of problems 11, 13, 14, 15, 17, 18, and 20, 22 onto Classroom for me. That's your classwork for today. 23 is a geometric application problem. We are going to be seeing a lot of these. So in this problem, you have to remember that the area of a rectangle or a square is length times width. So I'm just multiplying the length times the width in order to find these. Remember, they're asking me for the area of the shaded region. We did do one of these problems last week. So if they're asking me for the area of a shaded region, I want to do the area of the outer minus the area of the inner. And so that really means the area of the big the area of the big rectangle minus the area of the small rectangle inside. So essentially, like I said last week, it's like a piece of paper. I'm cutting out a portion of that area. So I got to take it away. Okay. So the area of the bigger one, okay, is going to be length times width. So the area, the length here is 9x minus 2. And then that's multiplying by the width, which is here, 2x plus 7. And then I'm going to subtract the area of the smaller one. So the area of the smaller one, length times width would be x plus 12, and then the width would be 3x. Notice I put these big brackets, guys, because I have to do the work inside the big brackets before I can do subtraction. So I'm going to start with this one over here. I'm going to rewrite this out. I'm doing a binomial times a binomial. So I need to do this 9x times the 2x times the 7. So 9x times 2x plus 7. And then next I'm taking this negative 2 and multiplying it by both terms. So negative 2 times 2x plus 7. Okay. Continuing that work, I'm going to distribute. 9 times 2 is going to give me 18. X squared. And then 9x times 7 is going to give me 63x. Then I'm going to do this negative 2 times 2x to get negative 4x. And negative 2 times 7 to give me negative 14. Okay. I want to simplify here. So I'm going to combine like terms. The 18x squared stays, the negative 14 stays, but I have to combine this 63 minus 4 to get positive 59x. Now this is going to be subtracting from whatever I get here in this product. So I have to multiply over here. So I know this is a lot of work, but it's all stuff. It's just combining everything we've been doing into one. So this is a monomial times a polynomial. So I'm just distributing that 3x to both terms in that parenthesis. So 3x times x is going to give me 3x to the power of 2. 3x times 12 is going to give me 36x. So I'm just going to bring that down because it's already simplified. And now I'm going to be doing this trinomial minus this binomial. Okay. I'm running out of room, so I'm just going to add a paper down here. Okay. So remember when we're subtracting two polynomials, we rewrite the first one. And then we rewrite the second one, but we change all the signs because essentially this negative sign is distributing. So this is a positive 3x squared. I'm going to change it to a negative 3x squared. And this is a negative 36x. I'm going to change it to a positive 36x. That's very important. We can't forget that. And then lastly, I want to combine like terms and put it in standard form. So the largest degree I have here is that power of 2. I have 2 of those, so I can do 18 minus 3. That's going to give me 15x squared. Then my next highest degree is the power of 1. I can combine these. I'm going to do 59 plus 36. That's going to give me 95x. And then lastly, this negative 14 comes down. It has nothing it can combine with. And this would be your final answer. This is your area of the shaded region. So this is the shaded region's area, and that would be your final answer. So a lot of work, but not too bad if you really take your time. Just make sure you're careful of errors here. All right, so if you're at home today, you owe me 11, 13, 14, 15, 17, 18. I'll also post that in Classroom, and then 20 and 22. Okay, so just 8 problems. All right, try those out. Let me know if you have any questions, and you're free to come to ACT Lab as well. Have a great day, guys.